This is a question and it is a tree that is given to you in question, and you have to solve it using alpha beta pruning. And I will tell you all of the values, and so that you will not get confused what is written here. This is A note, this is B note, C, D, E, F, G, H, I, J. These are the notes. It has two childs, 2, 3. It also has 2 child, 5, 9. It has only one child and its value is 0. It has 2 childs, 7, 4. It has 2 childs, 2, 1. It has 2 childs, 5, 6. I hope you can see this all. Now, alpha beta pruning can be done using DFS approach, depth first search. Okay, remember this thing. So you have to solve it using depth first search approach. Firstly, just mark the levels. So I am marking them like this. This level I am taking as maximum level. So I will write here as max. Okay. This level I am taking as minimum level. So I am writing here as minimum. This level I am taking as maximum. Alternatively, you have to do maximum. Okay. And in the last note where values are given, you don't have to do anything. So just understand this. You have to go using depth first search approach. So you will explore the nodes like this. Firstly, you will start from here. You will find this node. Then you will go there. No, firstly you will start from here. You will go there and then there, and you will find this node, and then you will solve this one. You will solve this for this node. After that, after solving this, you got some values. After that, you will got to know that it has one node also. You will explore this, then you will go there. You will change values according to the thing that this node is already explored. This node is having 2 childs. This child is not yet explored. This child has already explored. So this node will take values from this, the value of this node as it is. After that, you will go there and you will explore this one for this, and then you will find out that it has also one child. You will explore this one, and then after exploring these two, the value of this node will finally change, and then you will find out that you will go upwards and then do another things. Okay, you will compare it both of the values, and you will change the values if this any value according to maximum or minimum, and then you will go there, so on. So in this DFS approach, if this node is having 2 childs, one child is not explored and one child is not yet explored, it will check the value of that child which is explored, and we will go further, and later we will find out that this has also one value, and then we will compare both and then change the values. This is the way. I hope you will got it. Now I will tell you step by step, in a step by step way. And if you are not getting how to explore the childs, you have to use DFS approach, and just to practice this question again and again, you will get everything. So just start. You have to write some things in theoretical parts. Here, when you explore this, when you are exploring in DFS manner, you will find out the child of this node as 3. You will have explore E node first. So you will write here as theory, I will tell you, at E node. Okay, just to make a gap here. At E node, as it is maximum level. Level is max. This level is maximum level. Okay. So the write theory as initial value of alpha is equal to minus infinity, initial value of beta is equal to infinity. It will change it will remain constant. Okay, as I have told you already that as in maximum level, value of beta will remain constant, alpha value will change. So it has found out, when we are exploring E node, it has found out only one child. So we will write here as maximum of minus infinity comma 2 is equal to 2. So it will give the value of 2 E node. But when we are going from here to there, we will find out that it has one more child. So we will explore that one also. Maximum of 2, that comes from here. 2 comma 3 is 3. So E node value will become 3 and it will become 3 for E node. Okay, so just write here as alpha beta. Alpha is equal to minus infinity at first, beta is equal to infinity at first. Beta will remain constant, alpha will become 3, and this value you have to write here because you have found out the value of E node as 3 and it is a maximum level. So you have to write it like this: greater than or equal to 3. This is the value of E node. Okay, after this you will, after exploring this node, you will again go to the B node. You will go to the B node. B node will find out one child that is explored. This child is not yet explored. So it will take the value, minimum value of that. Minimum, see. It will take minimum value of that. And here we have only one node. So we don't need to compare minimum. It will take the B node value as 3. Okay. In the beginning, and we will write it as less than or equal to 3. It may change if another node value is less, as it is a minimum case, but here we have only explored one child. Now it will also change the value of alpha and beta. As initially it will be like this, minus infinity and infinity, but when we are doing DFS approach, these values also got changed and we have to write it like this. See this. At B node, just draw that diagram into your copy because I can't show you diagram and theory at the same time because of less space. Value of alpha is equal to minus infinity and beta is equal to infinity. But as it is minimum level, so just write beta value, alpha value will remain constant, beta value will change and it will become 5. It will become 3. Okay, you can write the theory just like this. As it is a minimum level, alpha value will remain constant, beta value changes. Okay, so just make it 3 because it has got that value from here. This node has got that value from this node, and here we will change the value of this. We will make it as 3 and this value will remain same. Okay, after this, after you explored this one, you went there again and then you found out F node. F node you have to explore now, and it will get firstly this one it will got. So you have to write it like this: at F node, alpha is equal to beta is equal to Now, one important concept is there. Alpha is equal to beta is equal to, alpha will become minus infinity, beta will become 3, because we can take values downside the tree. So this is the case. Now when we are exploring this, we will compare these things. Alpha is equal to minus infinity, beta is equal to 3. It has taken values from B node. We can take values downside the tree. So, what is the case? It is a maximum level, C, maximum level. So we have to take maximum values for F node. It has two child nodes, 5 and 9. Firstly, it will explore 5, 1. Okay, so maximum of minus infinity. As it is a maximum node, beta value will remain constant, alpha value will change. Minus infinity, comma 5 will become 5. Okay. After this, one important concept that is applied here is, here it will give values to alpha. Alpha will become 5, beta is equal to 3, and the condition is alpha is greater than or equal to 5. 5 is greater than or equal to 3, beta, that is beta. This condition is true. So when this condition is true, we have to prune it. We will not check its next child. It means that here when you are moving from in a DFS way, you will got this child also. But when you have got this child and you are checking it with alpha comma beta values, and you have applied the condition as alpha is greater than or equal to beta, this condition becomes true. So you don't have to explore this child, you can cross it. You don't have to explore this one. So the value of F node will become what it will become, as it is a maximum level node. So we have to take the maximum at maximum level. The maximum value of alpha is 5 here. So F node value will become 5. F node value will become 5. Okay. Beta is constant, alpha is changing, and it has given it the value as 5. So beta node value we have to change here also. Beta node value will become 5, greater than or equal to 5. Okay, I have less space. I hope you are getting this. This is 5. Now again, we have explored this, we are not exploring this, we are going back here and then we will go there. But when we are going back here, this node value is less than or equal to 3, this node value is greater than or equal to 5, and between 3 and 5, which value is minimum? Because it is a minimum level node, B is a minimum level node. Between 3 and 5, 3 is minimum, so its value will not change and it will remain 3 only. Now we will go upwards towards the A node. A node has 3 childs, but this child of A node is already explored, so it will give the value of A node as it is a maximum level node, so it will give it the value as greater than or equal to 3, and now in maximum level node, alpha value will change. So alpha value is previously minus infinity and beta value is infinity. Beta value will remain constant, alpha value will change, and it will become 3. Okay, I hope you are getting this. It has taken the values from that node which is explored. These two nodes are not yet explored. So this value is alpha value is 3, this value is infinity. Now we will go to the C node. After going from here to here, we will go to the C node. C node can take value from these nodes, alpha comma beta value from this node, because we can take values downside the tree. We can't take values upside the tree, but we can take values of alpha comma beta downside the tree. what I am saying about downside values are not taken in case of alpha comma beta. These values, the values of node can be taken. Values of nodes can be taken, but alpha comma beta values downside the tree can't be taken. So in this node, alpha will become 3, beta will become infinity first of all, because it has taken alpha comma beta values downside the tree from this node. This node has taken that value. So now we will explore C node. So see this, when we will explore C node, we will reach G node, and G node has one child which is having value 0. So just first write the values here, this value also. C node. At firstly, what I have done after exploring the F node, this one, I will go there is no change here, and after that I have changed these values, A node values. So I have to write this also. So write here at A node. Firstly, just write that thing also. Alpha is equal to minus infinity, beta is equal to infinity, and we have changed value it as alpha will become 3, beta will remain constant. Just write the theory. Okay. After that, what we have done? We have reached to the C node, and we have given that the values it as this. So I have to write this also. Step by step we have to write everything. At C node, just you write the values. Alpha is equal to 3, beta is equal to infinity. Okay. Now in C node only, we have got another node which is G, and it is having a child which is having a value 0. Okay. So the G node will also take the values from C node. It will take value of alpha as 3 and value of beta as infinity. Why? Because why it is taking? Because we can take values downside the tree. Alpha is greater than beta. Here you can check. No, alpha is not greater than beta. Infinity is greater than 3. You have to check these things also. And it can also give values to H child. It will give it as alpha is equal to 3 and beta is equal to infinity. We can take values downside the tree. Downside the tree we are giving values. Now we are exploring the childs of this. We got this node, and then we have to explore this one. See. Now at G node. G node, alpha value is taken as 3, beta value is taken as infinity, and G node is of maximum level, and we have to take this one 0 and maximum value. So we know that at maximum level beta will remain constant, alpha value will change. Alpha is equal to 3 here, and maximum of 3, 0 is equal to 3. So the value of G node will remain as 3. This value will become 3 as we have reached to its last node, last child. So this node value will become, one second. See, one thing here is, it is the value of alpha. Okay. Alpha value will remain 3 only, and the value of G node will become 0. Why it is so? Because here it has only one child, and the maximum of there we don't have to compare anything, so it will remain as 0 only. This node value will become 0. Here we have taken maximum among these two. Here we are not exploring this because alpha is greater than or equal to beta here in this case. So we will taking this value. Here we are also checking alpha comma beta values and here in this case g value will become 0 only. It has no any other child. After this, what you have to do? After this, go from here to there. C child. C child will find out that there is one child of it which is explored. It will take that value, and here as it is minimum level, so we will write it like this, less than or equal to 0. Okay, now after going from here to there, we reach to this child one. It has already taken values of alpha comma beta from here. So now we will go to H node. At H node is having two childs further. Alpha is equal to 3, beta is equal to infinity, and it is a maximum level, so beta level value will remain constant. See here at H node, we will explain first its first child. First child, maximum of 3, 7, which is the value of its first child. Maximum of 3, 7 is what? See here, before exploring H node, one thing is this. Here we have given value of C node as 0. Okay, so alpha comma beta value of C node will also change, as it is a minimum level and it has got value as 0. So alpha value will not change. Beta value will change and it will become 0. Okay, it will become 0 when we have arrived here in this point. So we don't have to explore H node first, but just check one thing. Here alpha value is 3, beta value will become 0 from here. So alpha is greater than or equal to beta condition is true here. See, I will write it. At C node, alpha is equal to 3, beta is equal to 0. We are getting. So alpha is greater than or equal to beta. 3 is greater than or equal to 0 is true. So we don't have to explore its child, which is this. This child we don't have to explore. So just cross it. You don't have to explore it. Okay. After this, you will go from here to there. A node, A child. You will go in A. In A node, it is having value as 3 and C node is having value as 0. These two nodes will compare. Which value is maximum? 3 is maximum. It has got the value of 3 from the here. So we don't have to change anything. After this, we will go from here to here. It will take value from these alpha comma beta. So D will take values as alpha is equal to 3, beta is equal to infinity. From here, this A node values of alpha beta. And it will give value to this child also and this child also. It will give value to this child as alpha is equal to 3, beta is equal to infinity, and similarly for this child alpha is equal to 3, beta is equal to infinity. Okay, now we will explore this. You can write it later also, but I am just writing in one go only. This will explore this one. We have to explore now I child. I child of this node is having two further subchilds. This child is having value 2. So first explore this one. Alpha is equal to 3, beta is equal to infinity, and we have to compare it with 2, and it is the maximum level node. So just write it. At I node, alpha is equal to 3, beta is equal to infinity, maximum of 3, 2 is 3. So alpha value will remain 3 only. Okay, and after this just check the next child. And is there any condition alpha is greater than or equal to beta? No, because beta is infinity. Next child of I is 1. You can see from here 1. So just check it also. Maximum of three comma 1 is equal to 3. So alpha value will remain 3 only. So at I node alpha is equal to 3, beta is equal to infinity. There is no need to worry about it. So just go to the next node, but before this find out the value of I node. The value of I node will be, which one is maximum among these two? Maximum of 2 and 1 is 2. So I node value will become 1, and we haven't got any case in which we have to prune it. We have to explore both of its childs. We have not got alpha is greater than or equal to beta case. After this you have to go in here, and it will find out that this node is explored, this node is not explored. It will take value from here and it will become 2. This node value will become 2, greater than or equal to 2. Okay, and it will also change the values of alpha comma beta. See, it is a minimum level, so alpha value will remain constant, beta value will change. What value it will take? It will make it as 2, so beta will become 2. Here 3 comma 2 value at D node, value of alpha is 3, beta is 2. So it is a pruning case. At D node alpha is equal to 3, beta is equal to 2, alpha is greater than or equal to beta. Okay, 3 is greater than or equal to 2. So we don't have to explore its child that is left, which is this one, J child. So just cross it. We don't have to explore it. J child we don't have to explore. So the minimum value, you don't have to do anything with it. Minimum value which is for D is 2 only. After that exploration of this is done. Exploration of this is not required. You will go to A node again. From here you will go to A node and you will find out the maximum value among these 3. 3, 0, 2. See, these 3, 0 and 2. Which is maximum? 3 is maximum, and it is already written here. So you don't need to change anything. If here you will find out the value as 8, suppose, so you will change it to 8. But you haven't found any greater value. If here you have found out value as 8, you will change it. But you have found out lesser values than this, so this will remain same only, and the value of A node will remain as A only. So I hope you got this. So the important thing in alpha beta pruning is that sometimes you don't have to explore a smaller child. In this case you don't have to explore this child. In this case you don't have to explore this entire thing, this H node and its further child. And in this case you don't have to explore this one. You don't have to explore this. And I hope you can see this. Okay, you have not explored this one, you have not explored this one, and you have not explored this one. So this is the pruning, and now you will calculate alpha beta cutoffs for this. It is easy, but just note one thing. You will got value of alpha comma beta something, and you forgot to check alpha comma beta conditions. Alpha is greater than or equal to beta. Then you will explore this also, this also, this also. and you will solve the question incorrectly. So always check alpha is greater than or equal to beta conditions. Now I will tell you alpha beta cutoffs.